Welcome back. In our previous section, we spoke about data structures and algorithms, in which we talk about arrays topic. We discussed in theoretically how array is stored in memory, how you can access using index of the array, the elements within array, and also we talk about the operations like accessing, modifying, and deleting an element within array. And also we discussed about time complexity per accessing element in an array, modifying elements, and also inserting element and deleting element. So now we'll talk about and we'll see hands-on how it works using Golang. Okay. So in Golang, I just created one function, one file, a main.go file, in which actually we'll start discussing and taking care of how the operations on array can be done. Okay. Okay, I will just create main function. In Golang, actually, arrays and slices both are there. Since we need to resize an array during modification, during inserting an element within array. So because of that, what we will do is we'll try to create a slice. Okay, slice can be created like this, and you can insert elements like one. Okay, so I'm just trying to created a slice here. This is how actually we are declaring and declaration and unit of slice. Basically array, both are. Our main focus is uh, our main focus is on see the what kind of operations we can do on arrays and the time complexity of accessing and modifying, inserting and deleting an element within an array. These are our main discussion as part of this session, right? So yes, here what we can do is we will try to print what are elements we have. Okay, println. We'll try to print array elements basically. We can use percentage of v for that. We can use array. Okay, we're just trying to print array elements. Okay, and this is just declaration installation, and we're just printing the array elements. Then how to access an element? Okay, accessing elements in an array. So it's very simple if you know index. Currently, what we will do is we'll try to access at position 2. Okay, element at so what we can do is okay, now array of 2. So this is time complexity of accessing an element is basically of 1 only, because constant time, if you know the index, then at one instruction only you can get that one, right? And modifying an element. Let us see like how it looks like now. We're able to access or not. Yes, element if you see 1, 2, 3, 4, 5, and element at index 2 is 0, 1, 2, that is 3. Okay. So now what we will do is we will insert and we'll modify it. We'll try to modify it. Modifying elements. So what we will do, this also will take of one time complexity only, because if you know the index, then it is easy. Just try to change the value at position 2. Okay. Let us print these values after modifying element at index. Okay. Try to print array again. So in this case, if you run this code, after modifying, if you see the position at 2, it becomes 6 now. Okay. Now let us insert an element. Inserting an element at position 2. Okay. So what we will do is we'll see that index is 2. Okay. Value, I can say we can insert 7. Okay. This is actually what we will do is we'll try to do append array of index, okay, comma, append integer value, whatever new value we are trying to insert. Okay. And then array of index all elements basically. Okay. So in this line actually we are trying to, okay, so we are just trying to insert the value 7 at position 2. Again we are appending remaining values actually, that's it. Okay. So this is insertion. This will take the time complexity of O of n, because we need to shift actually all the elements from the position 2 to remaining all the elements actually. Okay. Now what we will do is fmt dot printf after inserting 7 at index 2. Okay. The values are okay. Let us see this print values and then see like how it will be working the inserted value. If you observe this, actually, if you see this slice size becomes 6 now, and the element previously element is at 6, it is shifted one position now. It become like a third position, right? Okay. Let's move on and check this is the time complexity of open because we are shifting elements actually. And let's try to delete operation. Let's do the deleting operation at position again 2. Okay. Normally this time complexity also often we discussed theoretically also sometime back in the previous sessions. Now we will see in index again, right, equal to 2. Now error equal to append of error of index comma index plus 1 and all other elements. Okay. Now if you try to print this, dot printf after deleting at index 2. Okay. Let's print these values and check it out how all the operations will be working here. If you see elements 1, 2, 3, 4, 5 is there, while accessing element at index 2, we are receiving 3 at of 1 time complexity. After modifying element at index 2, we are modifying it to 2. Again modifying again takes of n time complexity only. Then the modified result is like this. And after inserting 7 at index 2, inserting that, this will actually takes of n time complexity because we need to shift all the elements from the position 2. So if you see that 1, 2, 7 inserted at position 2 and remaining values are shifted one position. Deleting element, once we delete the particular position, we are deleting element at second position. So after deletion actually position, second position, again we need to sync all the elements. So that's why it will take again warp and complexity. So overall this is about arrays and arrays operations and what is the time complexity to do any operation on arrays. Thank you.